Hello students, welcome you all to the video lecture on signals and system. Today we are going to discuss about the definition of signal and then what is continuous time signal, what is discrete time signal and what is one dimensional signal and multidimensional signal. Okay. So what do you mean by signal? Signal is one which carries some information and it is a physical quantity that varies with one or more independent variable. So the independent variable may be a time, space, pressure, temperature, like that. Okay. So for example, if you are sitting in the classroom, the faculty member is asking you some question, right? So particularly to you, they are saying your name and asking the question. So you will be rising up and giving your answer. Okay. So if it is so, out of 10 or 20 students, how you know that it is you? So you know by means of your name. Okay. So if they say, if they tell your name or registration number, according to that you will rise up and you will be giving your answers, right? So how we are telling that? Because they are giving the signal through speech, right? Through speech it carries some information. Through some information you are giving the responses. Okay. So a signal is one which carries some information and it is a physical quantity that varies with one or more independent variable. So in the overall signals and system we will be depending upon the independent variable which is time t. Okay. So here when you say the independent variable may be time space, right? So we are particularly depending upon the time t. Okay, so the continuous time signal usually we will denote it as x of t and discrete time signal usually we will denote it as x of n. Okay, so we will discuss what are all these things. So when you see these two signals, right? So it is depending upon the functional variable t, only one independent variable time t. Okay, similarly x also depends upon only one independent variable which is nothing but your n. Okay. So the signal, that is your music, speech, photo, heartbeat, all these things are signals. Okay. What is one dimensional signal? So one dimensional signal is one which is a function of only one independent variable. Okay. So you can write it as f of x or x of t. Okay. Or we can say that it is f of a, which is depending upon only one independent variable. So again the speech signal, it varies with respect to time, it is a one dimensional signal. Measuring of a temperature is a one dimensional signal. Okay. So usually we will represent your sinusoidal waveform. Sinusoidal waveform is also a one dimensional signal because it depends upon the time t. Okay. What is multidimensional signal? Multidimensional signal is one which depends upon two or more independent variable. Okay. So usually it is, if it is two dimensional, it is a function of x comma y. If it is three dimensional, it is a function of x comma y comma t. Okay. So for example, when you take a image, okay, you will be having a vertical coordinate and horizontal coordinate. Okay. So it depends upon two things. Okay, two functions. Two independent variable. A function which depends upon two independent variable is said to be a two dimensional signal. And then for example, if you take some 3D cartoon character, that is a 3D image. Okay, so it will be depending upon a three independent variable. So if you are considering a 3D movie, it depends upon three independent variable along with the temporal value. Okay, so three spatial and one temporal coordinates will be there. Okay, so 3D movie is an example for a four dimensional signal. So in simple I can say your measuring of a signal, okay, like a sinusoidal signal, square waveform, all these things are example for one dimensional signal, and the image is an example for a two dimensional signal. If it is a 3D image, it is example for three dimensional signal. If it is a 3D movie, it is an example for a four dimensional signal. Okay. Now again we have two types of signal. The major type of signal is your continuous time signal and discrete time signal, which we are going to discuss in signals and system. Okay. So continuous time signal is also called as analog signal. What is analog signal? It is defined for every instant of time. Okay. So if you consider a signal, for each and every value of t, you can find out some amplitude. For example, if suppose this value is 0, this value is 6. Okay. For each and every instant of time, you will find out some amplitude. For example, if t equal to 0, what is the amplitude? Amplitude is 0. If t is equal to 1, okay. If suppose my maximum amplitude is a, at t is equal to 1, the amplitude is a. If suppose I want to find out what is the amplitude at 0.5, that is also possible. It will be of a by 2, right. So for each and every instance, your signal has been defined. That type of signal is nothing but your analog signal. So if you take some square waveform like this, it is again an example for your analog signal, because it has been continuously defined. So you can simply say analog signal or continuous time signal is continuous in amplitude and continuous in time. Okay, CA and CT both. Your amplitude is also continuous, your time is also continuous. Now again, what do you mean by continuous? Continuous in the sense it takes all set of values. Okay, all set of values in the sense it will take integers, it will take decimal point values. Okay, for example, t may take values like 0, 1, 2, 3. Okay, also t may take 0, 0.1, 0.2, 0.3, 0.01, like that. It can take infinite set of values. Okay, similarly amplitude. Okay, amplitude also may be 0.5, it may be 2, it may be 3, it may be 1000, it may be 0.001. Okay, so all set of values from minus infinite to infinite, the amplitude as well as time can take. Okay, such a type of signal is nothing but your continuous time signal. Okay, and then discrete time signal. So from the name itself, what it has been defined, discrete in the sense, okay, it is not in a continuous. Okay, for only a finite set of values the time value exists. Okay, in another way I can say, here time is denoted by n. N is always the values integers. N can take only 0, 1, 2, 3, like that. Okay, so other values and all not at all possible. But amplitude, it can take all the set of values from minus infinite to infinite. It can take all the set of values like 0, 1, 2, 3, 0.5, 0.4, 0.01, all the set of values it can take. But time, always it is discrete in the sense it will take only a fixed values. Okay. For example, when you see this diagram, at 0 the amplitude is 0, at 1 the amplitude is 2, at 2 the amplitude is 3. What about your 0.5? There is no signal. 2.2, there is no signal. Okay, so in between the values, decimal point values of time, your amplitude does not exist. Only for discrete instant of time, only the amplitude exists. Such a type of signal is nothing but a discrete time signal. Okay, so in simple I can say discrete time signal is continuous in and discrete in time. Okay, and you can obtain DT signal from this signal into a sampler. So which will convert your DT signal into DT signal. Okay, so that process is nothing but sampling. And also you have to note that previously continuous time signal is denoted by x of t, discrete time signal is denoted by n. Okay, so always you have to remember this. Okay, continuous time signal is denoted by x of t, discrete time signal is denoted by continuous time signal, time is given by t, for discrete time signal time is given by n. Okay, thank you, thanks for watching.